In this video, I'm going to talk about momentum. Momentum is a word that you've probably heard quite a bit, especially if you're a sports fan. You think, oh gosh, that football player definitely has a lot of momentum, right? But it's also a physics term that has an actual equation and actual physics meaning. When I think about momentum, I like to think of it as mass in motion. Okay, so if I have a truck and I have a car, I look at this truck. If they have the same speed, the same velocity, if the truck is more massive, it will have more momentum than the car. If the car is going some speed and then it speeds up, well, then it has more momentum because it has more motion or more velocity. If we were in class at this point, I would ask you guys to tell me which letter we should use for momentum. We have lots of letters in physics that we use for equations, but we even go into Greek letters. M's are taken with mass, and big M means something else. So momentum is actually denoted by the letter lowercase p. So the equation for momentum is just the mass of the object times its velocity. Now, if you look in a textbook, you'll probably see arrows over the top of these. These arrows just means that this is a vector or that it has direction. So if I had these two vehicles and I decided this way was positive, the momentum of the truck would be big M times V, and it would be a positive value if they both have velocity V. The car would have momentum little m times v, but it would be negative because the velocity of the car is traveling negative. The car is traveling in the negative direction. When we think about momentum, a lot of times we think about the change in momentum, or delta P. The change in momentum would just be the initial momentum minus the final momentum. More oftentimes, though, you'll see this as delta P equals m times delta V. In this class, when we're not dealing with calculus, we're dealing with constant mass objects. And so the change in momentum, we have constant mass. It's only going to be the velocity that changes. Further on in your physics life, you might get into a case where the mass is changing. If the mass changes, the momentum does change as well. So let's talk about the scenario of a person who is going to throw a baseball. Here's their baseball hat. All right, so here's the ball. This person has to apply some force to that ball to get it to travel at some final velocity, V final. So if the initial velocity that it starts with is 0 meters per second, we could talk about the change in momentum of this ball. And let's say he throws the ball with a speed of 20 meters per second. All right, the direction of the change in momentum is going to be the same direction as the net force. And so this person applies a force to the right. That means the change in momentum, or delta P, will also be to the right, or positive. Now, if we're talking about then this person's friend who is over here, and she catches the ball, well, the final velocity and the initial velocity are switched, and she applies a net force in the opposite direction, or to the left, or negative. So the change in momentum that she imparts will be negative. So the change in momentum is in the same direction as the net force. This idea of the change in momentum would get a little bit trickier if instead of this girl catching the ball, she took a bat and hit the ball backwards, right? So the ball then travels this way. Now, if the ball starts with an initial velocity of 20 meters per second to the right, and then she hits the ball and then it travels in the opposite direction, let's say with a velocity of negative 30 meters per second. Well, what would be the change in momentum? Let's just make it easy and say that the mass of the ball is 1 kilogram. Well, then P equals M, the change in momentum is the mass times the change in velocity, or 1 kilogram times the change in velocity. So you have to take into account that it is negative 30 meters per second as the final velocity minus the initial velocity of 20 meters per second to give us a momentum change of 50 kilograms times meters per second. This is the unit for momentum, kilograms times meters per second. It's a weird unit. At this point, that's all it is. It's not, we can't reduce it like we could turn a kilograms times meters per second squared into a Newton. You can't do that with momentum. It's just kilograms times meters per second. It's super weird. But this is going to be 50 negative. So the change in momentum is negative because the net force that the bat imparted to the ball was in the negative direction as well.